one. Number one, we're looking at this data right here in the box. All right, so here's all the data in the box. You look through the data, you have numbers in the 60s, 70s, 80s, and 90s. So your stems are the tens digit, 6, 7, 8, 9. Then you go in order and find, you have a 65. I suggest you cross it out, you put the 5. Then 67, you cross it out, you put the 7. 68, you cross it out, and you put your 8. Then you move on to 70s. And you got a couple 73s, so you mark it, cross it off. You got a couple 75s, so you put the 5, cross it off. You got a 6, 76, you put a 6 and cross it off. 79, there's all your 70s. Again, if you make a mistake and find out you missed one, you just go back and add it. You have to erase, move numbers, and okay. 80s. Well, you have an 80, so you put a 0. There's no 81. There's a couple of 82s. You put a couple of 2s there. You got an 83, so you put the 3 over there on the leaf. 85, you put a 5. A couple of 87s, you put that. And then 88, you put an 8. Then you have a 90, a couple of 91s, 92, 94, 95, 98. There's your stem leaf plot right there. 10's digit is the stem. 1's digit is the leaf. Okay? Now, what's the highest score? That would be right down here, 98. Now, this next question I crossed off because the key said uniform. Somebody else's key. I don't agree with that, but I also don't know what to really call it. If you turn this on its side and you made a histogram out of this data, okay, you have 3 datas between 60 and 70. You have 8. Sorry, I got that wrong. This should be 6. This should be 6, and that should be 8. So this should be up here. That will be like that. So it would look like that. Okay. 1, 2, 3, 4, 5, 6.
The 90s have.
95. Okay, that makes 7 here. So what we really have here is 7, 6, 8. Okay. So this one's a little bit taller. I don't know if I'd really call it uniform. So it's not exactly uniform because it's not really a rectangle. It ends up being 3, 6, 8, 7. So, you know, it's not exactly a rectangle, but it's not exactly symmetrical either. So it's a hard one to really classify as what it would be. Now, if we had another one down here, like in the hundreds, that was like 3 or 4, I'd call it symmetrical. Okay, like that. But right now, the most I would maybe say is skewed left, possibly. But after that, you know, I just stretch it out. All right, so which will we use to describe? It'd be the median. And the main reason we want to use the median is because we got these smaller numbers down here, kind of, you know, most of your data is upper 70s, 80s, 90s. Those 60s are kind of outliers a little bit. So we use median. Okay, so this is not necessary here, but if you want to like map it out, you can see what's happening. You know, this is 13, you got 2 14s, 3 15s. So you could map it out to kind of see the numbers. It was not required for this problem. It's just kind of as a viewing tool. So the actual, well, actually, it did say list the actual data. Sorry, just up there. So this is the list of all the data. All right, you got 13, 2 14s, 3 15s, 1 16, 2 of these, and so forth. That's the entire list. And there should be a 22 here cut off. Okay, what is the minimum entry? That's down here. What's the maximum entry? That's up there at 22. The mode, basically that's the one that has the most of them, which you can clearly see right there is the highest point in the curve. And the shape is skewed left. Most of your data is up there, but there's a few outliers, some data over there on the left side, pulling it down, pulling it to the left. So it would be called skewed left. Remember, the most common mistake here is to say skewed right because that's where all the data is. Skewing is away from the bulk of the data. So wherever the tail is, that's which way it's skewed. Follow the tail. Number 3, sketch a generic histogram that's symmetrical. Okay, so you have a tall tower, matching towers here, matching ones here, matching one here. That's a symmetrical look. It should be something like that. All right. Histogram that's skewed right. It doesn't have to look exactly like that, but basically, you have more data here, and it kind of tails off that way to the right. Okay, so follow the tail, which way it tails off to. Okay, 5. Using this data right here. Now, the first thing about this data, the problem is it's not in order. It's usually a good idea to always write this in order. So when you do that, just cross them off. So you got 19, 20, 21, 2 22s, a 23, 25, 30, 31, 42. Always helps to do that, especially when you're trying to find the median. If you don't write it in order, you can't find the median. Okay, so the mean, you add those numbers up and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you add them up, you get 255. Divide by 10, 25.5. What's the range? Again, I like it written this way, but I will accept either way, 19 to 42 or just 23. The median. Here's why you cannot find the median the way it is. There's 10 data points. So that means 4 here, 4 here. You can't say it's in between those two numbers. It has to be in order. Because right now, it's those two numbers. If I jumbled the numbers up again and had 2 different numbers in the middle there, it'd be changing. It has to be in numerical order. So basically, you wipe off those 4, wipe off those 4. There's your median, halfway between 22 and 23. You add them together and divide by 2. The mode, which number occurs more than anything else, that would be 22. There's 2 22s and then one of everything else. Okay, are there any possible outliers? I mean, 42, you could say, because you got your 19s and the 20s and lower 30s, so I'd say 42 is an outlier, because it's kind of further away than everything else. Which would you use? You use the median. Again, when you have outliers, you use median. If there's no outliers, we use the mean. But if there's an outlier, we use the median. Okay, looking at the box and whisker plot, and remember, this could be written like this. It could also be written like that. So it can be horizontal or vertical. What's Q1? Okay, Q1 is right here. It's the first line of the box, 60. Q3 is this right here. The IQR is from here to here. So remember, you can write 4 or you can write 60 to 64. Either answer is acceptable. What's the minimum and maximum? Well, the minimum is down here, and the maximum is up here. Okay, be careful. Remember, if this is on a number line, and the number line goes from 50 to 70, the minimum is not 50, the maximum is not 70. The minimum is where this dot and this dot for the maximum are on the whiskers. Okay, those are the minimum and maximum. It doesn't matter what the number line is, how big the number line is. It's the numbers on those dots. What's the range? 58 to 66. Or just 8. What's the shape? It's pretty symmetrical. Okay? If you pull it over, it might be exactly the same. Let's see. 2 here, 2 here. 1, 2, 3, 4 here. 1, 2, 3, 4 here. Yeah, it's exactly symmetrical. You could fold that in half on the median and everything would line up. It doesn't have to be that perfect to be symmetrical, but it is exactly symmetrical. Now, what percent of the data is between 60 and 62? Well, remember, they're called quartiles. Okay? So right here is 25% of the data. 64 to 66, 25% of the data. 58 to 66, 100% of the data. Okay? So quartiles breaks it up in 25% sections. Okay, so here, you got your data. Again, you want to put it in order.
You want to give my pencil back?
Okay, so as I was saying, you want to put these in order first. Okay, so we look for the smallest number, it looks like it's 12. We're gonna write small, so we want to get it in order. And then you go from there. We got 14. We got two 15s, it looks like. We have a 16, and you should have done this. If you didn't, you should be doing it now. 17 is the next number. I don't see any other 17s. So I got 19 here. Okay, 20. I got 1, 2, 3. So 20, 20, 20. 21. It looks like I got 1 there. 22. I got 1 there. I don't see any 23s. 24s. I have a 25. 26. There's 2 of them. Does not look like there's any 27s, but there are 2 28s. A 29. There's no 30, but there's 3 31s, 4 31s. Oops, I missed a 23. So I'll squeeze 23 in there. And then there's a 32 and a 34. Not ideal, but we go from there. Okay, so finding Q1. Okay, well first you gotta find the middle. So how many are there? There's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25. 25 is nice, an odd number. That means 12 on one side, 12 on the other, middle number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hey, look at that. Kind of cool. The median ended up being right there, that extra number. Almost like it was meant to be. I did not do that on purpose. So there's 23 as the median. That's right here, Q2, that's the median. Now, where's Q1? It's basically the middle of this half. So there's 12 numbers there, so we count up 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? And let's see, 17, actually that should be 18. So it's halfway between 17 and 19. 17 plus 19 divided by 2. Q3, same thing. We count up 6. 1, 2, 3, 4, 5, 6. It's going to be between 29 and 31, which is 30. The interquartile range, well, that's from 18 to 30. I don't know what the deal is here. That's totally wrong. 18 to 30. Or you could put 12. And this is probably going to be messed up now. So my upper number, is there a 35 that I missed? I don't see a 35. Okay, so let's scratch this. Okay, so my smallest number is, what's 12. My largest number is 34. 34. Okay, then I draw my line. Okay, so my Q1, which is 18. Let's think about where 18 would be. 34 minus 12 is 22. Divide by 2, that's 11. So halfway, this point in the middle would be about 12 plus 11, 23. Okay? Halfway point's about 23. So where would 18 be? About right here. We're just estimating. Okay? It's a pretty good estimate. Q2 23. Well, we just said that would actually be the middle, so that's right there. That's 23. And where would 30 be? You know, estimate about there. There's my box and whisker plot. Should look something like that. All right. So this rectangle is uniform. The mean and the median are the same. Okay. This next one is skewed right. Most of your data is up here. The tail goes off that way. So the median is lower than the mean. Symmetrical, they're exactly the same. Right down the middle, mean and median. And here, most of your data is here. Follow the tail, skewed left. Therefore, the median is higher than the mean. This one's bimodal. Because you got here and here tied, two modes. Okay, and here we have the median is the same as the mean. All right. If you turn these into decimals, it's okay, but you should have the fractions written down. So what's probably a randomly selected person had 2 accidents. Okay? So here's 2 accidents. There's 89 people that had 2 accidents out of the total of 323. What's the probability that a driver 26 to 40, okay, 26 to 40 had 3 accidents? Well, it's given that you're 26 to 40. That means this is your denominator. And 3 accidents, that's your numerator. What's the probability a driver had 1 accident given they were above 40? Well, above 40 means this is my denominator. 95. 1 accident, 62 over 95. Given they were 17 to 25. Well, given means that's my denominator. That's the wrong thing. Yeah, that should be 78. I don't know what that I'm looking at from. Oh, that's backwards. That one's backwards. This says given 25, 17 to 25. That means that's my denominator. 3 accidents is 40. That previous answer would have been given 3 accidents and their age was 17 and 25. So that was the backwards one. Okay, what's the probability that a driver was 26 to 40 years old? Okay, well, how many of them are there? 150. How many people are there total? 323. What's probably that driver had 2 accidents and was 17 to 25 years old? So 2 accidents and 17 to 25. That's this interaction right here. So they're here and they're here. Remember, it doesn't say given that they were one or given the other. It just says what's the probability of both. Well, this is the interaction of 17 to 25 and 2 accidents out of the total 323. What's the probability that a randomly chosen person had 3 accidents? So you just want to know total of 3 accidents is right here out of the total number 323.